Okay, we're going to look at making a linear model. The reason you would make a linear model is if you have data and you want to analyze the data to make predictions for something that may happen in the future or may have happened in the past. So I'm just going to use an example here where the data that we're collecting on a smaller scale is how many hours a student has studied for an exam and the score that they got in the exam. For instance, I'll say 2 hours of studying might earn a student 80% on an exam. 5 hours, 100, 1 hour, 70, 0 hours might give 40, 1 hour, also, this is another student, might earn a 50, 3 hours. Okay, so I'm just making these up, and I'm going to make a scatter plot showing the relationship between how many hours a student has studied and the score that they have in their exam. And I'm going to do count off in 5s on one side and 20s on the other. And this is a real informal graph, so when I go ahead and plot my points, they're going to be all over the place. And I'm going to expect that they're all over the place because this is data, and data is not perfect. Data is realistic. Okay. So I made the scatter plot, and if you look at these points, they're kind of all over the place. They're not linear, meaning that they don't make a perfect line if I connect the dots, but scatter plots should never be linear. But what we do here is we're going to use this information to help us make a model. And so what I'm going to do is I'm going to take a straight edge and I'm going to estimate a line of best fit. So using all of these points, I am going to estimate the best line that I can that describes the pattern that's going on with these data points. So there's my line of best fit. Your line of best fit might not be exactly like my line. Your line of best fit won't be like anybody else's line, but if you try to estimate to the best of your ability, you can at least make a model so that if you had to predict exactly how many hours you would need to study to get a 70 or a 90, this would be more than just an educated guess. This would be a model that you could use to try to make that prediction a little more accurately. This is also what we would call a positive correlation. If you see, there is a relationship here. The more hours that they study, the higher the grade. Other kinds of correlations that you could possibly see, I'm just going to draw another first quadrant here, is if after drawing a scatter plot my lines went down, this is what we would call a negative correlation. If I drew a line of best fit like this, the line has a slope that is negative. I can also have the points have a negative correlation, but this would be, we'll call this a negative correlation, but we can use other describers like this is a weak negative correlation. We call this one a strong negative correlation, and right here is an example, here's my scatter plot, of a weak positive correlation. They do kind of go in a positive slope. Or if I have points that are all over the place and your line of best fit could be pretty much anything, this would be in no correlation. And so the data here might be hair color and scores that they get in an exam, something that's not related. And so if you were to plot the data points, they wouldn't show any pattern. Okay, so now that you know what a linear model is, I want to talk about how to use your TI-83 to make a linear model from data that you are given. The only difference is when the TI-83 draws a line of best fit, it is as accurate a line of best fit as you can come up with. This is something that, as a human, we can't do this in our heads. This is something that is a computer calculated line of best fit, and it's a lot of different steps. So let's just start with our data. And so I'm going to come up with some data points really quickly here, and these data points are going to be random. I am going to make my x's go in ascending order just because I want to, but they may not. And I'm just coming up with some different random numbers that I'm going to use to show a relationship. And I'm purposely making this relationship be a positive one for no reason. Okay, so what I want to do is I want to find a linear model. And when I'm looking for a linear model, I also want to find the equation of a line of best fit for the model that we are making. So I'm going to use the TI-83 to do this. So we're looking for a linear model. We want the calculator to make a scatter plot, and then we want to have the calculator draw a line of best fit and also give us the linear equation for the line of the best fit. So, all right, so I'm going to turn on the calculator, and my first task is to put this information in the calculator. So the button I'm going to push is Stat, and I'm going to hit Enter. I have L1 and L2. These are lists. My lists right now are clear. If your lists aren't clear, all you have to do is arrow up so that you're highlighting L1 or L2, whatever list is not clear. And if you hit Clear, Enter, that will clear everything out of your list so you don't have to go through individually and delete everything out. So I'm going to go ahead and start putting in the numbers into list 1, and that's going to be all of the numbers in my X column. So that's -10, -3, -1, 0, 8, and 10. I'm going to arrow to the right and putting all of my numbers from the Y column. 30, 42, notice I push enter after every number, 58, 70, 80, and 112. It's really important that my lists are the same length. I have the same number of elements in L1 that I do in L2, because these are going to be perceived by the calculator as ordered pairs. So if I have more numbers or more elements in one list than I do the other, you're going to get an error down the line and it's not going to help. So one thing you want to do is just make sure that they're the same length. Now what I'm going to do is I am going to turn my stat plots on. That's me telling the calculator we're about to analyze data. So I'm going to hit the second button, and stat plot is written in yellow behind my y equals. So when I hit second and I hit y equals, it gives me what looks like 4 different plots, plot 1, plot 2, plot 3, plot, and they should all say off at this point in time, but I want to turn the first one on, so I'm just going to push enter. And then it's automatically highlighting on. I'm going to hit enter again. That turns my stat plot on. All of these other choices here are just showing you what kinds of graphs, and by default, everything that is picked is what we want. This is a scatter plot. It's going to draw its information from list 1 and list 2, which we put the information in, and we also get to pick what kind of dot it puts in the scatter plot. Okay, so I turn my stat plots on. If I hit enter, it will make sure on is highlighted. And I'm going to go back to the home screen by hitting second, quit. Now what I need to do is I want to look at my scatter plot. So I'm going to hit the zoom button, and I'm going to pick zoom stat. If you arrow down, zoom stat is number 9, and hit enter. And if you notice here, I have the first and second quadrant, and all of the points that we put in L1 and L2 are now plotted. So the calculator essentially made a scatter plot. Now I'm going to tell the calculator that I want it to draw me a line of best fit, and so I'm going to hit second, quit to go back to that home screen. And now that I'm at the home screen, I'm going to hit second, calc. Actually, I don't want a second calc. I want to hit stat. Sorry. I'm going to go back to the home screen. I don't want second calc. That's a different one. I'm going to hit stat and arrow to the right where it says calc. And number 4, where it says linreg, basically that stands for linear regression. It's the same thing as a linear model. I'm going to hit number 4, and that's going to put in my home screen linreg ax plus b. After this, you still want your cursor right next to it, so I haven't pushed enter or anything. I'm going to hit second L1, which is behind the number 1 key, comma, second L2, which is behind the number 2 key, comma. The comma is above the 7. And then I'm going to hit vars, arrow to the right, and then hit enter 3 times. It's a lot of stuff. Okay, after you hit the enter 3 times, it's going to give you y equals... Should we do this over? Because it's really bumpy. Okay. It's going to say y equals ax plus b, and it tells you what to plug in for a and what to plug in for b. I'm just going to write that down really quickly. I'm going to round to the nearest hundredth. Y equals 3.74 times x plus 62.84. This is the linear equation of the line. If I want to look at it, if I hit push graph again, I will see the points, and I'll also see that the line is now drawn. And this is really useful for you if you're asked a question about finding a linear model and you want a very accurate equation for the line of best fit. And it always comes out, if you do it in the calculator, it always comes out a long decimal. And so you will probably have to round to the nearest tenth or hundredth, depending on what the question says. But it doesn't get more accurate than this line. The best thing to do to learn how to do this process is to repeat it a few times. After a while, you'll start to know it by heart. The only other thing I want to say is I'm just going to hit second quit, so I'm back at the home screen, and I'm going to clear this out. Now if I hit stat enter and I want to do another problem, I'll have this old information in here, and I'll have to arrow up and hit clear enter and start all over. But if I'm doing this again for a second time with different data, this time when I go to the stat plots are still on. They stay on until I turn them off. So when you go in later and you're doing a different problem and you want to graph a line in your calculator, it's going to give you an error if your stat plots are still on. So when you're done doing a linear model type question, you're going to want to go in and turn off your stat plots. And you can do that with the process I just showed you by pushing second stat plot. Or you can say, you can go into y equals, and you can arrow up and you can enter, and that will turn plot 1 on or off depending on if you want to on or off, but that's a second way to do it. Also, I want you to notice y equals has in it that equation that the calculator came up with for the line of best fit that we wrote down here. When we were at the home screen and we hit stat and arrow to the right and found linear regression, we were telling the calculator to do 3 things. Look in list 1 for all of your x values, comma, look in, let's go back there. Look in list 2 for all your y values, comma, and when we hit vars and arrow to the right and pushed enter 3 times, well, here I just hit it twice so far. This last part was me telling the calculator to put the equation in y1 and draw that line for us. It's giving me an error right now because I cleared out my list 1 and list 2, so there's no data there now, but that was how the equation found its way into the graphing editor, and eventually you'll see the line now. You won't see the plotted points because I cleared out the information. But like I said before, this is one of those things where you want to just keep practicing it over and over and over again, 3 or 4 times, and you'll start to be able to do it by heart. And that is it.